Hello, everyone. Welcome to the second episode in our series. Today, we are meeting with an incredibly interesting founder, Senna. I'm so excited to have you here today. I was wondering if you could maybe start off by telling us a little bit about yourself, your startup, and then we'll get into hearing a little bit more about what you've been up to.
Hi, my name is Senna Ferguson. I'm the founder and CEO of Ugsei Robotics, and we're currently developing an autonomous modular drone that we hope will solve a lot of the needs of the emerging, logistics challenges that, developed countries are facing, as well as solve other problems that currently are unfulfilled. So, I guess we can begin. Okay, so like I said, founder and CEO of Ugsei Robotics. As you can see, a little sneak peek. That is our current Skyboard version. It is a modular drone, so it can be equipped with various modules depending on what industry demands are. And our design can actually be scaled up and down from a meter by a meter all the way up to 10 meters by 10 meters, depending on what, the customer requires. So currently, there are huge problems with current drone technologies. Typically, drones today, they just cannot lift enough weight or have a far enough range, and they just cannot be adaptable to dynamic situations, leading to a lack of adoption in most industries. So when you think of logistics, we'll talk about, some of our competitors in a couple of slides coming up, but just can't lift enough or fly far enough to like meet customer demands, which is a huge problem. So that's the problem. Right now is a perfect time for autonomous logistics drones because one, battery technologies have just gotten a lot better. So we can now actually have the capacity to fly further than before. And also with the emerging AI technologies, a lot of our systems can actually be automated. So one person can monitor up to 1,000 drones without any problems. And there'd be actually minimal sort of glitches or anything like that where a drone would actually crash into other stuff. Whereas before in the past, just this was not possible. So our current team is made up of two people, myself and Ryan Walter, who's my COO as well as co-founder. I studied at Ryerson for aerospace engineering, and then I also won multiple engineering competitions while I was there, and I was the only freshman to ever be awarded the Norman Esch Innovation Grant, which was kind of cool. After university, I actually developed my own social brand where I now have over 850,000 followers across, YouTube, Instagram, and TikTok. And I also founded an XCS Labs, which was a Web3 company during the whole COVID situation, where it generated over $1 million in revenue, and that was quite good. My co-founder, Ryan Walter, is an actual professional aerospace engineer, a commercial pilot, and he's been in the aviation industry for over 15 years in both commercial and military applications. He was a former head of flight test engineers for the Royal Canadian Air Force, a U.S. Navy test pilot school graduate, and he also has now his executive MBA. And he's been a huge help. We consider him the optimistic skeptic. So, obviously, with the new emerging technologies, we have a lot of claims of what we want the drone to be able to do, sort of how far it can fly, how well it can fly, and stuff like that. And he's been pretty much the one who questions everything. And I know if I can get it by him, then we're pretty much set. And so far, there's been no hiccups, which is good. So the global autonomous delivery market, which is essentially $0 right now, globally will be worth roughly $450 billion. This is by ARK Invest research, so they're quite trustworthy. These aren't just our numbers. Um, so in terms of drones and last mile deliveries, it'll be worth $450 billion dollars. And it's going to be a huge market, which is essentially starting from scratch right now. So there's no existing companies that have a concrete foothold in the whole drone autonomous delivery platforms. There are companies working on it, which we'll touch on in the next slide. But right now, it's pretty much a fresh start, a clean slate, which is quite rare for a market that will soon be worth a lot of money. So here is the competition, like I mentioned before. You have the bigger players like Google, Amazon, and Zipline. If you look at the largest photo, that is Google's Wing. Their company is called Wing. It's a subsidiary of Google, and they've spent roughly $2 billion on this current iteration of the drone. And as you can see, it's quite complicated. There's a lot of complicated parts on it. The airframe is quite messy, which is, what I think. Um, and it can only lift roughly 5 kilograms and fly around 20 kilometers. and it's mainly going to be used to deliver food and small parcels like that. And then, of course, you have Amazon in the top right corner, who have, obviously huge logistics provider, and that is their current iteration. Similar to Google's, it can only lift roughly 5 to 10 kilograms with a similar range of 20 kilometers. And then the number one logistics provider in the world actually is Zipline, and they're the bottom right corner, and they have over 2 million miles logged, but they mainly deal with, stuff in Africa. But this new iteration of theirs, same category, only 5 kilograms, can't fly too far, and it's extremely complicated to build. And that's where we come in. So this is the Skyboard. This is our take on what we believe the future of drone logistics will look like. The current version on your screen right now is the actual 2 meter by 2 meter platform. So it's our second smallest, and it can lift roughly 100 kilograms and fly 50 kilometers, which is unparalleled in its performance. And underneath it, you'll see crate. That's just for show. That's actually just one of the modules that we can attach to it. So that can be swapped out for other things like in farming, whatever's needed for that, and we'll touch more on that later. So compared to our competition, we just have unmatched payload and range. A lot of this comes from our EDFs, so electrically ducted fans. We don't believe in open propellers. That's typically the annoying hum that you'll hear. It'll sound like a mosquito flying around above your head. EDFs are unique in that you can actually insulate them with sound dampening technologies. So they're actually a lot more quiet, and they are a lot more powerful in terms of the output, but they do consume a little more energy, which is a trade-off that we're willing to take, especially since batteries are getting so much better. And like we said before, we don't just do logistics. It can be equipped with other modules, which our competition just can't be adapted to. So, like I said, it's one platform, multiple sizes, from 1 meter by 1 meter to 10 meter by 10 meters. And the key thing is that it is modular. So I keep hitting on it, but it is important that the single drone platform can be adapted to various market needs that, maybe we don't foresee. So someone, can build their own module for it and adapt it to the drone, which is something we highly encourage. Obviously, there's going to be a lot of autonomy built in. So when you have a swarm of these working together in a logistics network, they can all work together. And another unique thing about our drone is that it's extremely simple. There's only 9 moving parts, which we'll touch on in the next slide, but that leads to a streamlined manufacturing process, which ultimately reduces cost, which is why we can offer it for a lot less than our competition. And it can also just be scaled a lot more quickly that our competition just can't do. So, like I said, the underlying magic, we only have 9 moving parts, which is extremely rare. There's no flaps on our drone, there's no ailerons, no like ducted work like that. It's just the blades, little actuators, and the center of the drone is actually just one monocoque. So it can be made pretty efficiently by one person. It will only take them about an hour to lay the carbon fiber. And then after that, you just put it in an oven. It bakes, becomes extremely strong, and that's it. It's done. We don't need to, come in, make some cuts after, attach flaps to it. It's done. So it's extremely streamlined. On top of that, it takes the best of vertical takeoff and landing while having the efficiency of a plane. So like a fixed wing, which is newly emerging. They're called VTOLs. eVTOLs is when it's all electric, and it's the technology that we're going to be adapting into our drone. And also, the most important thing, like I said before, it can just be equipped with multiple modules. So one person can have one drone, he can use it to dust his crops in the morning, and then later on in the afternoon, use it to help him move construction material across his property or whatever, which is, I think, pretty important that it can be used for multiple things. So our business model consists of three revenue streams. The first one is just hardware sales. So we actually just sell the Skyboard to various companies or various customers, depending on what they want. So if there's someone in farming, we sell them the drone plus the module to do farming. Or if a company wants, a swarm of them for logistics, we'll sell them like 100 of them in bulk. The next one is software licensing. So we are going to be developing our own autonomous navigation slash swarm management software, which we believe will be quite good. And if we do get it to a good enough point, we can start to license that out to other drone companies, who just want to use our software with their hardware. And then finally, the ultimate business model for us would actually to become the logistics provider. So we ourselves become the end-to-end solutions, delivering packages for people. One unique use case that I've heard of recently is that people actually hire Ubers just to deliver packages to their friends across cities. So now there is some risk to doing that. Obviously, you're leaving your package with a stranger, but with this, we'd be able to do it with a drone, you know, quickly deliver something to a friend, and it'd be good. And next is our traction. So we've already built our first prototype, which is quite good. We actually just finished building a couple of other components. We 3D printed them out of nylon X, which is nylon slash carbon fiber. Um, so far, so good. No problems with it. We are now looking to build our actual MVP, which is the one you're seeing on your screen now, the 2 meter by 2 meter version, which will be capable of lifting 100 kilograms with the range of 50 kilometers. Um, that is pretty much what we're looking to build now. And we believe as soon as that is built, we have an extremely unique marketing strategy for it, where we know, knock on wood, it would go extremely viral. That's where my background in social media comes in. So I know how to make, I guess, viral content, you could say. So we'd be quite confident that it would, get a lot of attention. From there, we're just going to be filing patents, doing some legal stuff. And then once all of that is set, we'll then start showing it to possible customers as well as future investors for the next rounds of funding. And then we'll start to build out our partnerships with other companies as well. And that's it.
Wonderful. Thank you so much. That was a great presentation. I know you also brought some different pieces and components that you said you'd be open to sharing.
Yes. So this is one of our braces, which we've 3D printed from carbon fiber. As you can see, there's still glue on it, so it did just come off of the press, as you can say. But we iterate a lot of our components quite quickly, and we're able to do that with 3D printing. Now, obviously, it's maybe more expensive to do 3D printing compared to injection molding, but you can iterate like part after part, which is nice. And yeah, and then another part, which I think is kind of cool, is we actually 3D printed our propeller blades. So
Very
this is about a 35 centimeter diameter. It's quite powerful. It can actually produce 20 kilograms worth of thrust. That's what we pushed it to so far. So we haven't, put it to its limits yet. It's kind of dangerous, but you know, we're able to do all that in-house, with no outsourcing, which is pretty cool.
That's very cool. That's very cool. And thank you for showing us that.
No worries.
I do have a few questions if you don't mind getting
Yes.
into a little Q&A session. So I'm
Mhm.
curious if you could just dive in a little bit deeper about you and your co-founders' experience and expertise and why you're the right people to be building this company.
Yeah. I think Ryan and I, we complement each other pretty well. He comes from a background where there's a lot of, rules in place, a lot of regulations in place. He knows how to test equipment, especially for military standards. He's in charge of acquiring, or was in charge of acquiring, planes for the Royal Canadian Air Force. So he knows all of the processes and procedures that are needed for highly regulated industries, which is extremely important. And he double checks everything that I do, which is very important. In terms of me, I've been self-employed, building companies on my own for the past 10-ish years. Doing social media on your own is quite risky. You either make it or you don't. And then also being able to, you know, sort of go into a new field like Web3 out of nowhere, which is not my background. I never studied coding or anything like that. But being able to quickly learn how to code, and build out a product that generated over $1 million in revenue, you know, just because it seemed like the right thing to do at the time is is kind of a good skill to have. We can adapt and then also double check that all of our procedures are pretty good, which is important. Yeah.
Awesome, awesome. And so I'm curious to know what inspired you guys to form this startup. Um,
Mhm.
I know obviously you both have the professional expertise and experience, but how did this shape the approach you're taking? I found it really interesting that you were using the fans over propellers, and I'm assuming that has something to do with something you learned along the way.
Yes, so I studied aerospace engineering, like I said, and before I actually moved to doing drones, I actually wanted to build eVTOLs, right? There's a huge craze of, air taxi services, flying cars and stuff like that, which is eventually what we would like to do. But all of those businesses are quite cash intensive. And, being able to make that money back is sort of a longer road map than simply doing drones. So we changed our path from making eVTOLs down to because we realized we could actually just shrink the technology and it has the same benefits as an eVTOL. So we decided just to start with drones. And then as soon as that became, as soon as we started generating a lot of revenue with that, then we would start generating or developing the eVTOL platform, which is, I think flying cars is quite inspirational. No one likes traffic, especially here in Toronto. Oh my gosh, the GTA traffic is terrible.
I definitely agree with that. There's nothing I hate more than sitting in traffic, and I get so much rage for no.
It's terrible. And I mean, the stress it adds to your life, the years it takes off is ridiculous. So the end goal also is just to build a flying car that, is widely adopted. But that's later. That's later.
How does it outperform its competitors?
Um, it outperforms them in a couple of ways. So one, if we talk about the cost it takes to build each drone of a similar size. So let's just use our 1 meter by 1 meter platform compared to Google's version of it. It costs pretty much the same amount, but the way we build our drone just utilizes the money more efficiently than them. So we don't have all the flaps, which, like I said, takes a lot of time. All the small details that are required for their drones to fly efficiently is something that we work around it just because of our philosophy of actually moving the fans themselves instead of having all these flaps on the plane. Um, so we reduce costs a lot by that, but also because we did reduce a lot of costs, we can put that money towards just making our drone perform better. So we can make it, have higher performing parts, which is important for lifting more weight, which the other companies just don't do for some reason. I don't know. They're stuck in their philosophy. One thing you learn in university is that as soon as someone learns something new or has been taught something a certain way, they will look to adapt that to everything they do. And I think just a lot of these drone companies from the other companies are sort of stuck in their way because of who they decided to work with, which is, you know, it's up to them, right?
Discuss. So one thing that I found really interesting was that you mentioned that there's only nine moving parts to your drone. How
Yes.
is this different from, other drones? I'm definitely not an industry expert. I know a lot of the people listening
Yeah.
won't be an industry expert. So what does that mean, for you guys, which may be different for other drones?
Yeah. So in terms of a quadcopter only has four moving parts, but it's quite limited with its capabilities. It doesn't have the best flight controls and stuff like that. When you start looking at planes, those typically have pretty good flight controls, like they're pretty stable. They can go through turbulence and stuff like that. But all of them require sort of flaps, so ailerons, tail flaps and stuff like that. And we've figured out a way to reduce those flaps by simply just using thrust vectoring. And so it's sort of new. It's a new technology that hasn't really been tried this way, but using thrust vectoring, we can actually eliminate all the flaps, which no one's ever tried before, which is quite strange. I don't know why they haven't. I guess, like I said, they're stuck in their ways, but it comes down to just trying to build something differently that has surprising benefits that have never been tried before.
And to just shift the conversation a little bit to go back to the prototype. So what milestones have you hit so far, and what's the next version that you're going for?
So this prototype works flawlessly. It demonstrated our mechanical processes, so we know for a fact that we're able to control the drone itself with just these nine moving parts, right? There's no confusion there. There's no weird problems that we saw when we were testing it. It works as planned, which is good. The next steps is just to build the commercial version. So our prototype here is version 1. It only has, you know, 3 ducted fans, whereas our actual MVP versions will have a total of 6 ducted fans. They're twice as powerful, twice as efficient, and that's just what we're looking to build. So yeah.
So when you talk about commercialization, I'm curious to know what industries you think will adopt this, I guess the fastest. I know you mentioned flying cars, which
Yeah.
seems like an incredible idea. If it got
That's
made,
way
that
down the
might be
line,
a
way
little
down the
bit down
line.
the line.
Yeah.
So when it
Yeah.
comes to, industries adopting this technology now or, in the near future, which industries do you see adopting it the fastest?
So there's two main adopters I see pretty quickly, actually. The first one is agriculture. So, people with farms, they're already actually adopting drone technologies. So DJI has a good farming platform drone that they use. It can lift a lot of weight and stuff like that. And farmers have actually been adopting that recently, which is pretty good. It's able to reduce costs for them to spray their fields, with pesticides and stuff like that. So our drone would just be able to do that better for cheaper. So I think that'll be adopted there pretty quickly. The next one is actually with law enforcement. So here in Canada, we actually have, I think, the government announced that there's now going to be like $1 billion invested into border security. So instead of having helicopters monitor the border every single night, what you could have is pretty much a swarm of skyboards, which are able to monitor, like 100 kilometers to 1,000 kilometers worth of property lines, right? And then you can scan it, pretty easily with just one person. And I think that'll be a huge use case. And then typically with that, because it's with law enforcement, they'd be able to work around whatever, regulations there are possibly stopping that.
That's true. I'm curious to know, do you think people are going to be very open to adopting these flying drones? Like, I think that thought kind of scares a lot
Mhm.
of people, and maybe there's a
Yes.
lot of people who are a bit skeptical and maybe not wanting to be involved in that world. How do you think about people adopting to this?
No, 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 that's a fair question. I have seen a sort of cultural shift, if you want to call it that. Before in the past, when drones were new, everyone would sort of freak out that there's a drone over their head. Now it's sort of more just of a nuisance, right? You sort of hear the drone, it's annoying, you hear the buzz, and it's more annoying in terms of, it being there instead of people freaking out over the fact that there's drones in the air. I think if drones are to be widely adapted, they just have to be quiet, right? They can't be ugly. Quadcopters, as widely used as they are quite ugly, right? And that's a problem. And they do make a lot of noise. So as soon as the noise gets down, people won't notice them as much. It'll just be like birds flying over their head, stuff like that. There shouldn't be a problem.
Interesting. I know one thing you just mentioned was the drone regulations.
Yes.
I'm assuming that this definitely impacts the way you design, develop, and, plan to
Mhm.
sell drones down the line. I was wondering if you could talk a little bit more about those regulations, how you've kind of had to navigate. Are they changing?
Yes. So the drone regulations are quite strange in the fact that there's a lot of regulations in place already before the technology has actually developed. And we see a lot of the regulations actually being changed, especially in America. A lot of regulations have been slashed, they've been pulled back, and they've actually been now pushing for autonomous drones as well as eVTOLs to be used and adapted. I know they're worried that China will pass them in the technology, so they're sort of wanting to promote it in a way, safely, obviously. And I think a lot of the West will follow suit just because they don't want to be left behind. But there are a lot of industries that actually we don't actually see regulations as being a hindrance. So if you're on private property and you fly it at a low enough altitude, you're actually fine. There's no problems with you flying it on your own property as long as you're in like a rural area, obviously not in a city. So there's a lot of use cases there where people can actually use their own drones without any problems. On top of that, there's a lot of places, far out where, delivering, medication, emergency supplies, stuff like that, where regulations sort of get pushed around. So it's not too big of a problem. There are a lot of industries that we can adopt it to that don't have regulations.
Interesting. That's really good to know because I think that's something that a lot of people would also be skeptical about is all the regulation. So it's
Yeah.
interesting to hear that things are changing. Maybe some situations aren't as strict or severe as we think.
See, in cities, it's quite strict,
Yeah,
right?
yeah,
That's
yeah.
like with buildings and people, it's but in a lot of other cases, it's not strict. Yeah.
Yes, good to know. So I guess my last question is for you is what's the long-term mission here? I know you mentioned
Mhm.
flying cars super, super down the line and who's to
Way down the line.
um
Yeah.
but yeah, I guess maybe just for the time being or the next few years, like what do you hope to accomplish? Where do you see this company going?
I see autonomous drones helping out a lot of people, and the goal is that we are the number one manufacturer of drones for the world, in terms of logistics, provider, stuff like that. We want to be, just because we believe our design is the best, that we can, help the most amount of people with what we build. So we obviously want to build a lot of it. And then from there, we will just reinvest all of that into building new technologies, right? Like I said, the flying car is the next step after this one. We want to develop new electric motors that don't use permanent magnets, new battery technologies, stuff like that. It's just we believe that we can solve a lot of problems with, adopting new technologies, and this is just sort of the first step with drones.
Awesome. I think those are all the questions we have for today. So I just want to thank
Okay.
you for taking the time to meet with us. I know I learned so much. I'm assuming everyone watching will also learn so much. So I also appreciate you sharing your expertise and taking the time to talk to me today. But yeah, I will also leave all your links to like, LinkedIn and all like that in
Okay.
the description as well. So people can also, be able to find you and follow through with what you're doing.
No, perfect. Thank you very much, Emma.
Thank you so much. Take care.
Bye.
Bye.